questions during this uh, during this session, please do use the chat group. Please try and remember to mute yourself, and if the co-host can just help me to mute everybody so we don't disturb the presenter. We have a very special guest with us today, this evening. And this man is extremely busy, and we've been trying to get him on for a while. We're very honored, as usual, as always, to have him come and speak with us. This session should take around 45 minutes to an hour at the very most, allowing time for some questions towards the end. You've probably seen him in a lot of YouTube videos with hundreds of hits. You can find him on YouTube. You guys have all probably seen the posters now. His name is Dr. Imran Tabrizi. He's a very good friend of mine. So he was a former A&E medical doctor who used to work with my brother, who's currently also a medical doctor in emergency medicine, based here in London. And he's going to be sharing with us today the benefits of Kangen water. What is Kangen water? What is this electrolyte reduced water that everybody keeps talking about? How does it pertain to the health? How does it help us? And but it will be explained in a very simple way for us all to understand. So these are some of the videos you guys probably all seen on YouTube already. So I am now going to hand over to my good friend, Dr. Imran Tabrizi. So please help me give him a warm welcome. Imran, over to you. There you go. You're unmuted.
Hi there. Good afternoon, good evening, good morning, wherever you are in the world. It's a very, it's a pleasure for me to come on. It's been a while since I've actually done one of these presentations, so I'd like to thank Anthony and the rest of the team for inviting me along to actually come down and do this presentation. Now, normally when I do these presentations, I usually start off by just giving a little sort of intro about myself, which Anthony has kindly done, but just to give you a little bit more perspective, I worked in medicine for about 15 years in the emergency department. I trained here in London, did my degree about 2003 years ago. Seems like ages, but through that journey, I learned a lot about how we do things in the medical profession. And that one of the things that happened during that journey while I was working in A&E, I met this chap called Mark Tapp, who is Anthony's brother. And one of the things that we both seemed to agree upon was that we felt that there was certain gaps in the medical profession, certain things that we felt was lacking. So for instance, one of the frustrations we both had was that there was many old people who would come in with loads of ailments and they'd be on multiple medications. So you had people who were on a diabetic pill, or you had someone who had a blood pressure pill, or somebody who was on some sort of proton pump inhibitor to try and reduce the acidity in their stomach, and various other medications. And these are people who probably in their past, when they were growing up, didn't think that when they reached their 6th decade of life, that's what they'll be doing, popping pills, So it was quite a frustration for us. And we also thought that, well, perhaps maybe we might be losing the battle against chronic medicine because everything requires a pill. Now, in our days of training, what we believed was that, you only really went on medications for a short period of time. Medication was there to kind of buy you some time before you could find a solution to the problem or the underlying problem. And the other thing that we also thought was that when we treat patients, we're looking for the underlying cause, not just saying, okay, if a patient comes with this, then you just match them up with this medication and then say goodbye. Unfortunately, medicine has come that way. If any of you, I don't know if any of you know who the father of medicine is. The father of medicine was a man called Hippocrates. And what did Hippocrates used to say? He used to say, let thy food be thy medicine, let thy medicine be thy food. I would say that the compass heading in medicine has changed drastically since then. The medical profession, unfortunately, has been fraught with a lot of, politics. I would say that it's been affected by, capitalism, economics, law, and all of these things have a profound effect on the way in which medicine is being steered. So as a consequence, what you get as an output is you get a situation where it's no longer about the problem at hand. It's about what's the cheapest way we can solve this problem without any comebacks. It becomes almost like a sort of like an economically based type system, like a car. When you bring a car in, you know, you've got the person who is going to try and get to the bottom of the problem and fix the car, but then there may be other ways of trying to cut corners so that you don't spend too much time on that. You managing your overheads and trying to minimize the overheads and maximize your profit. So medicine has unfortunately suffered that. Another industry is the agricultural industry. So time and time again, you're going to see this kind of issue. So what is the answer to that? And we're talking about people's lives here. We're talking about health. So this is why myself and Mark Tan decided that we were going to embark on a journey together where we would try and fill those gaps. If you go and see a doctor today, a doctor will hardly ever sit down and talk to you about your nutrition. What he'll say was you need diet and exercise. And unfortunately, by just saying that and not focusing on the detail, then those people are going to suffer. Ladies and gentlemen, the devil is in the detail. What you eat, what you drink is what you become. And therefore, it's very important for us to know that we're getting the best of the best. So naturopathy is what I decided to go and look into. For those of you who don't know what that is, and again, it was something that myself and Mark decided to embark upon. It's basically, it's a way of trying to treat patients using natural remedies rather than resorting to things made in a lab, like drugs. A crude way of looking at medicine today is by summarizing it with just these things. The only treatments that you can provide in the medical profession is drugs, surgery, and psychotherapy. Those are the three main things. Other than that, there are adjuncts, there are additional things. And I'm not trying to knock medicine because I practiced it for 15 years, probably longer. And it does actually have a lot of benefits, especially when it comes to acute problems. If you come in with a broken arm, we can put something, align it, straighten it, put it back in position, and then it will heal. I give that analogy because that's a very similar analogy to what naturopathy is. There are certain principles that we have to learn in naturopathy. And the reason why I'm making such a big putting a lot of stress on this is because Kangen water, which we're about to talk about, does satisfy that criteria to a degree. Naturopathy is about looking at things slightly differently. We have to change our mindset about how we approach medicine. One of the ways we can do that is by thinking about working with the body. We try to work with the body. We have to change our mindset about certain things that we do in medicine so that we can benefit from something like Kangen water. So I'm going to start off with a story just to give you a kind of like a taste of where I'm coming from. A man goes to a store and he buys himself a fish. The fish is inside this bag of water. He takes this fish home. He loves this fish. He puts it in his aquarium. He observes it every day. It's dancing around in the water. He's happy. Fish is happy. 1 week goes by and the fish starts to look a little bit sluggish. The fish starts to sort of slow down. And so he gets a bit worried. So he goes to the doctor and he asks the doctor, he said, listen, my fish, it doesn't look like it was the first week. What do you think I should do? So the doctor says to him, I think you should give him some antibiotics. Put some antibiotics in the water and that will help the fish. He said, okay, I'll try that. So he goes and gets the antibiotics. He puts it in the water and the fish starts to take it all on board. And believe it or not, the fish starts to jump up and down and start moving around again. Another week goes past and the fish starts to become sluggish again. And then suddenly the fish turns on its side. And he's very devastated about this. And unfortunately, the fish dies. So he goes through the whole process again, buys another fish, goes through the same thing. This time, the fish did the same thing again. After the second week, it starts to get sluggish. So this time he went to a naturopath. Can anybody tell me what the naturopath told him? Any ideas? The naturopath would have turned around and said to him, why don't you change the water? So the subject to this, as you know, Kangen, change your water, change your life. So why did I bring that story into account? Why I brought that story is because it gives you an idea of how we should look at things. Sometimes it's very simple. It's just simple things that you need to do. You don't need to go and take antibiotics. You don't need to resort to, you know, this whole sort of a huge hammer to slug a nut. It's not about that. It's about looking at things objectively. So change your water, change your life. So why Kangen water? What is so special about this water? Well, many of you have all seen the demo. The demo tells you all about the water and what are the three main properties. The three main properties are alkalization, antioxidation, and microcluster. These are three mantras. This is like holy trinity. This is what all Kangen people know about. And what are the benefits of that? Or why, how does that benefit the body in any way? Now, there are a few things I want to cover in this thing, in this particular talk, because there have been some news that has come through about our understanding of those three things. We'll start with alkalization, and what I'll do is I've always been used to doing things on the board. So what I'll do is I'll share my screen and I'll put up some things on here as we go along. And I think the reason why I do it this way is because I like to do things from first principles to kind of explain things from the basics. So I'm going to share my screen with you, which is here. I don't know if you can all see that. Can you see? Oh, let's try that again. Okay, so you should be able to see a white screen in front of you. Okay, so what I'm going to do here is just kind of note a few things down. So just to kind of give you some sort of insight into what we're talking about. So we're talking about alkalization. Now, alkalization is based on a scale. Yeah. Now, you've all heard of what's known as the pH scale, I imagine. Yeah. So the pH scale goes from 1 to, I think it's, hang on, what's that? I'm going to do that. Let's get rid of all that. Right. Okay, so what we have here is we've got a scale, and the scale goes up to 14, I think. Yeah. So pH goes from 1 to 14. Now, what does the word pH mean? What does pH stand for? pH. Yeah. Now, it's important to understand what this configuration means because in order to understand this, we need to address a few basic points. So the first thing we need to look at, first of all, is we need to try to understand the difference between this, H plus, and H2. Yeah. Usually it's a 2. Well, we put H2. Right. Right. So what is the difference between these three things? Yeah. Hydrogen, H plus, and H2. Now you're all familiar with the periodic table. I don't mean to embarrass anybody here. I don't mean to turn this into a kind of like a lecture, but unfortunately it's going to have to, because if we're going to understand some of these issues, then we need to understand a little bit of basic science. But I think the purpose of this is so that we can appreciate what we're dealing with. So I'm just going to bring up the periodic table for a second. Let's bring that up here. There we go. Just a basic periodic table is coming up in a minute. I'm just going to bring that up just to show you. Right. So you're all familiar with this thing here. Yeah. Periodic table. In the top left-hand corner, you have H. Now, all of these are all elements: hydrogen, helium, lithium, beryllium. We don't have to cover all of this, but H is the one I want you to focus on. Now, hydrogen is an element. Hydrogen in here refers to the hydrogen atom, right? Now, the hydrogen atom, as we know, contains, and I'll draw it here, usually it contains, let's put it here. So this is hydrogen here, yeah? It has normally 1 neutron. Now, there are different types. There are some with 2 neutrons and 1 proton. But in this case, to make it for simplicity, we'll just say 1 neutron and we'll say 1 proton. Yeah. So it has a positive charge. And it also has a negative charge, which is here. Yeah. So you've got here a hydrogen atom, which contains 1 proton, 1 electron, and 1 neutron. So basically what that means is that what we have here is a situation where you have, keep on doing this thing. Let's get rid of that. So what we have here is a situation where we have, and we'll list this here, 1 proton, 1 electron, and 1, okay. Right, so we've got here 1 proton, which is represented by the black, sorry, the green. The green is the, and then 1 neutron. As a matter of fact, we'll get rid of the neutron because we're not really going to be concerned too much about that at this stage. But why I put it in there just for completeness. So we'll get rid of the proton, sorry, the neutron. Right. So you've got 1 proton, 1 electron. One proton. So what happens here? You've got a balanced. This charge on this particular atom is 0 because you've got proton represents positive, electron represents negative. They both cancel each other out. So as a consequence, what you have is just 1 hydrogen atom. The electron, the reason why I put this circle here is to represent the fact that it goes around the outside. It's lighter and it goes around the proton. And the proton and the electron are in balance. So this is your hydrogen atom. Now, what's this one here? H plus. H plus is just the proton, which is basically just this. Yeah. So that's your proton. H plus is the proton. H is your hydrogen atom. And last and not least, you have here H2, which is the molecule of hydrogen, which is basically the combination of this added to this. They're both joined together. Now, the thing to remember is that usually when you have a situation like this, where you've got 2 electrons, electrons usually like to go in pairs. That's the reason why hydrogen prefers to be in this particular configuration as a gas, and that is what's known as hydrogen, molecular hydrogen, or hydrogen gas. So that's the difference between these 3. Now, why do I bring these 2 together? Why am I focusing on this? Is because what we want to do is we want to understand what pH is. So pH, as we know, has a scale of 1 to 14. pH. Now, P, you'll hear people say potential of hydrogen. Well, pH is actually, P is actually supposed to be a mathematical term. And what P means is negative negative logarithmic, and we usually represent concentration with 2 brackets, or concentration of whatever's inside it. Yeah. Now, negative logarithmic concentration, that's what P stands for. And some of you are probably sitting there thinking, what the hell does that mean? Negative logarithmic concentration? I'm lost. Good. I'm glad you're lost, because we're going to explain. Basically, all P is a measuring tool. It's measuring the concentration of something. And what is it measuring in this case? Is it measuring H? Is it measuring hydrogen? Or is it measuring the protons? So straight away, pH is actually a misnomer. pH does not mean negative logarithmic concentration of hydrogen. pH means negative logarithmic concentration of protons, which is the H plus. So when these protons are in our little beaker, when we talk about, like I say, we get a glass here, right? and we fill this up with some stuff. So we put some liquid inside here, right? And we put this liquid here like this, black. So we're going to fill this up with water, yeah. And what we're measuring is we are measuring the stuff here. We are measuring basically H plus. Yeah? This is what we're measuring. We're measuring protons. We want to know how many of these things are inside here. Yeah? So if there's loads of these things in, yeah, if we put loads and loads of these protons inside, then what we have, if we keep increasing the concentration of these protons inside this, is that an acid or is that an alkali? Well, the clue is in the word negative logarithmic. When you use the word negative, what it does, it flips the scale upside down. Less is more and more is less. So if you have loads of these protons in here compared to another beaker, which has not as much, yeah. So imagine this has like, say, 1 million. So this has 1 million of the 1 million of the protons in, and this one only has, say, 1, which will represent by rubbing out some of these. Yeah. So now we've only got just a few protons in here, right? And what I'll do is I'll represent it by making the protons smaller. So there you go. There's a little green thing here, but you've got loads of these inside here. The difference between these two is that what you have on the left is your acid, and what you have on the right is alkaline. Yeah? Because you've got more protons. If you've got more protons, that's what makes it acidic. Now, we've already just said more is less. So what that means is that what you have is a situation where 1 is 1 million and 14 becomes just 1. It's actually more than a million. It's like 1 times 10 to the however much. But the point we're trying to make here is that when you're at the lower end of the scale, it's an acid. When you're at the upper end of the scale, it's alkaline. And the pH is supposed to represent the concentration of protons in the liquid. That's what defines whether something is acidic and alkaline. And this refers to all substances across the board. Now, in this particular case, we are measuring the concentration of protons in water, Kangen water specifically. So when you hear, for example, that we're interested in the pH of 9.5, which is a number that we get thrown at us all the time, which is round about, let's have a look, round about here, 9.5. Yeah. What does that tell us about the water? It tells us that the pH of the water is going towards alkaline because 7 is in the middle, isn't it? Yeah. 7 is in the middle. 14 is this end, 1 is this side. Actually, it's probably even better if I do this. So we know that when we take, for example, our pH tester and we add it to the water, if it's pH 7, it's normally green, isn't it? Huh? When we start to get acidic, we start to go into the orange range. And when we start to measure pHs which are higher, which means they're alkaline, then we get into the sort of purpley range, don't we? Yeah. So that is what represents the colors. The pH tester gives us an indication of whether it's acidic, central, or acidic, normal, or alkaline. And it's a measure of what the concentration of protons are. So the more protons there are, the more it goes orange. The less protons there are, it goes towards purple. And if it's somewhere in between the green and the purple, which is usually sort of bluey, kind of purpley, then what you have is you've got your pH 9.5, which is right about there. Yeah. So straight away, we're trying to distinguish and understand why we're getting these kind of readings, because it's important for us to understand that what the difference is and why the pH scale is the way it is. So once you've understood this part, then the rest becomes a little bit more, well, we can start to apply this to what we do. Now, unfortunately, there's a lot of people out there who will have a conflict about how this works. People will say, oh no, this is not good. As a matter of fact, I was looking online and there were some videos that say alkaline water is not good for you. There are actually some doctors who actually say alkaline water is not good for you. So what are you going to do when you've got people that come to you and say to you, but I've read that these doctors tell you that alkaline water has no benefit whatsoever. It has none of those things that they're saying. Well, herein lies the problem. What I've just shown you here is what we're taught in school. What they don't teach you in school is the differences between caustic alkaline and just alkaline water. Because alkaline water, when you've got a substance like water, water is usually recognized by the symbols H2O, isn't it? Yeah, 2 parts hydrogen, 1 part oxygen. Yeah, and remember we were looking earlier at this thing here. Yeah, periodic table. Well, this is what we're talking about. Oxygen is here. Now, the periodic table is split up into groups. You've got group 1, 2, 3, 4, 5, 6. Oxygen is in group 6. Hydrogen is in group 1. So when you have oxygen, this particular atom, when you try to represent this, so we've represented already, we represented hydrogen here, didn't we? With 1 electron on the outside and 1 proton. Yeah. When we start to introduce oxygen into the mix, so we'll represent that with O. What you have here now is a situation of where you have oxygen, which now we don't need to introduce the protons, but just for completeness, there'd be 6 of these protons inside the atom. But we're more interested in the electron configuration. The electron configuration, as I said to you before, when electrons group together, they like to group together in pairs. So my question to you is, when I decide to draw hide this oxygen atom here, which has 6 electrons in its outer shell, would you say that this atom is happy? The answer is no, because in the outer shell of this atom, there are 8 electrons. There are 8 spaces. And when you start to arrange these atoms in certain ways, they like to follow a certain configuration. They like to rest in a certain way. So atoms on the whole have 8 electrons in its outer shell. The first shell has 2. So usually in the inner shell, which is the center, let's go back. Yeah, let me just put that back. So this 6 on the outer shell. So when we talk about the inner shell is, so we represent that by here, another shell here like this. And that shell will have 2 electrons of its own. But we're not interested in that right now. What we're interested in is the outer shell. So the outer shell has 2, 2, and 2. This atom is not happy because it hasn't completed its 8 configuration. So in order to get happy, what it can do is we can get rid of these 2 electrons here. Actually, we don't have to get rid of it. What we can do is go back. Right. So what we do this time, instead of putting it with all 2 like this, we can have 1, 2, oxygen here. So you've got 2 electrons here, and then you have these 2 here. So these 2 pair with each other, these 2 pair with each other, and then what happens is we can then take this hydrogen, right? And we can put this to pair with that one. And then we can get another one, pair it with this one. So herein you have your H2O. So you have your oxygen here, the 2 hydrogen atoms here. So get rid of these O's because it's confusing the whole thing. Okay. So what we have now is you have 2 hydrogen atoms Right, you got one hydrogen atom here, one hydrogen atom here, and then you got your oxygen atom in the middle. So what you effectively have now is you've got your water. So this is water here. This is basically normal tap water. Now, does normal tap water just have H2O? No, it doesn't, because there are other things in the water. There's arsenic, there's sodium, there's potassium, there's calcium, there's other things in the water. There are things that make the water hard. The two main culprits are calcium, magnesium. They tend to make the water hard. So if you're living in places like London, they tend to produce scum, or they produce this kind of lime effect. And what happens is that they clog up your machines. And that's the reason why you're encouraged to clean your Kangen machine regularly to get rid of all that calcium and magnesium. And what you do is you then have a system where the water becomes slightly softer, and that's your H2O. Now, what we were saying before is that in amongst this beaker of water, you've got H2O, but you also have protons floating about as well. And the floating of those protons, which you then test, will then come out with a pH of 7 if you're just testing tap water. Yeah, so that means that you have still got protons in there, but it's in the normal range. It's in the middle range. If we start to take some of those protons away, then the water starts to become alkaline. And if we add protons in, it becomes acidic. So straight away, you can now understand how your Kangen water machine works. Your Enagic machine has plates, electromagnetic plates, which are made of platinum, and those plates extract the protons off to one side and produce acidic water, and the other side produces alkaline water. And that's basically using what's known as electrolysis. If you remember, I don't know if when you went to school, if you learn about these things where you have this electrode that sits in here, another electrode that sits in here, and then you get this situation where you have the cathode, which is the positive side, the anode, which is the negative side. That's what your machine is. Your machine is an electrolysis machine, which is separating the water out. So when your tap water goes in, you produce water that comes out of the back, which is acidic, which is this one here. And you have the alkaline water, which comes out the top, which is the alkaline water, which is pH 9.5, 9, or 8.5, depending which setting you put it on. And when you test this, this comes out purple. And when you test this side, it becomes yellow. That's what you're producing. That is what the electrolysis machine is doing. It's ionizing the water so that you can actually produce water which has got protons in, and the other side which has got less protons in, which makes it alkaline. Now, this is basically creating an alkaline and an acidic solution. But in school, you're taught that if you were to take the acid and mix it with a metal, say, it might dissolve that metal or eat that metal away. But you see, what we have to realize is that we are talking about a different type of acid. We're talking about caustic alkaline and caustic acidic, which is where inside this liquid, it's not just water. It's not OH2. It's not two hydrogens oxygen. What you might have in here is HCl, hydrochloric acid, or hydrosulfic acid, or nitric acid. So where you're not, in that case, what we're doing is we're not dealing with the oxygen atom connected to two hydrogens. What we're dealing with now is we're dealing with nitrogen, which is in group 5, chlorine, which is in group 7, and sulfur, which is in group 6, and the same as oxygen. The sulfur? Yeah. So what you have here is a situation where the presence of these other elements dictates how strong that particular acid is at, for example, breaking things down. Water is a neutral substance. It doesn't have that effect. So there is always confusion in the medical world when you talk about alkalinity of water. So they say, for instance, right, so the reason why I'm bringing this up is because now I want you to try and think about the human body. How is this beneficial to your body? I'll tell you how. When you drink this water, where does it go? It goes into the stomach. Now, what is in the stomach? Correct. Acid, right? Usually it's usually hydrochloric acid, which is in your stomach. What is the pH of that? Well, if you were to measure the pH of the acid in your stomach, what would it be? Would it surprise you to know that it's actually less than 1? It's actually 0.5. The reason why I know this is because we've done tests where we take a tablet which has a pH tester and we've actually put it in the stomach using something called the Heidelberg test. It's a machine which measures the pH of acid in the stomach. And what we did was, now this is all stuff you've never heard of because I've done this test. I actually had a patient who came in, I put the Heidelberg test, I put the tablet in his stomach, and I gave him some Kangen water, pH 9.5. Yeah, 9.5 alkalinity, poured it into his stomach. What do you think happened to the pH when I added alkaline water to his stomach? What do you think the tablet came back as? Would it surprise you to know that it had no effect whatsoever? And I'll tell you why that is. It's because it comes back down to this concept of the number of protons in the liquid. This is what they don't teach you in chemistry. Even though you have protons in here, so of course on this side you got 1 million, we said, or we'll call that 10 billion, and on the right side you got one proton. The fact that you've only got 1 proton in it, if you add this beaker of 1, if you imagine in here little balls, supposing you've got this is 1 small green ball, and this side you've got 1 billion big balls, which is acidic. When you add this 1 small ball to this side, what do you think is going to happen? Is it going to change this much? It's not, is it? It's going to be 1 billion and 1. On this side, there'll be 0. It's going to be completely alkaline. Yeah. But what you've done is you added 1 to 1 billion. But it doesn't cause the pH of this to suddenly go alkaline. Why is that? Because what we're dealing with a dilutional effect. You're adding alkaline water, which has only 1 proton, to 1 billion, you get 1 billion and 1. So what you have here is because you've got equal caustic effects. They don't have the capacity to add alkalinity to this to bring the pH back the other way. Where you see that is when you use something which has more caustic effect. So for example, if you take sodium hydroxide, which is, again, if we bring up the periodic table, sodium hydroxide is Na, which is in group 1, O, which is oxygen, and it's got hydrogens in it, NaOH. When you add something like this to the mix, sodium hydroxide, you are adding a different chemical in. Now you've got sodium in here, which has a certain gravitational pull on the oxygen and the hydrogen. So here you've got OH2. This is H2O. OH would be just this. Now, if you have OH, this has a negative charge on it because this electron becomes separate, so it becomes negative. Because if I take this away, if I take this hydrogen away, or this, yeah, what you have here now is an electron which is unpaired. Is this atom happy? No, because the outside is not complete. So what we do is we get sodium, which is in group 1, and we put it next to this. The sodium atom is slightly bigger. This has an exertional effect. And remember, sodium also has protons inside, which is about, where is it? What number is it? If I bring up the periodic table again, it will tell us. The periodic table says then sodium has 11. It's number 11. So it has 11 protons inside. So those 11 protons, in addition to its additional electrons, will exert a force on here. And that force creates this chemical that draws on what it gets attracted to. And as a result, can push this whole pH the other way to something like 12 or 13. Now, how do I demonstrate that? The same patient who I gave the Kangen water pH 9.5 in his stomach, when I added it to it, his pH did not change. It stayed the same. It stayed as 0.5. When I added bicarbonate of soda, which is sodium hydroxide, what that did was it brought the whole thing up to 8. It brought the pH to 8 because of the caustic effect. Now, this is what is missing in our teaching. They don't explain this to you. They think that alkaline acid are two opposite things. You add the other base, and they call the acid the salt and the base, and when you mix it together, it produces it neutralizes it. Doesn't work if you're talking about water, because water pH is about numbers. It's about protons. It's about the number of protons you have. The more protons you have, it's acidic water. But if you add alkaline water to acidic water, it's not going to have any effect. It's just going to change. It's not going to bring the pH back to 7. It doesn't work like that. So that's a very important principle to understand when we talk about the power of the water, how it affects. So when you drink Kangen water now, when people turn around and say to you, oh, it neutralizes the acid in your stomach and therefore you can't digest food. This is one of the major arguments you're going to hear people say. But that's because they haven't done the Heidelberg test. They don't know that. But I agree, if you take sodium hydroxide or ammonium chloride and drink that, it's going to cause a major effect. And that is what's going to cause what they call alkalosis. Yeah, because when you have an acidic change as vast as that, as big as that, not only is it going to affect the cells, it's going to affect the blood as well. And when it gets absorbed into the blood and it starts playing around with the pH of the blood, then you get what's known as an alkalosis. Then the body goes into a kind of shock system, and then the body tries to compensate by doing things like trying to push off or breathe out the CO2 in order to bring the pH down. You get these compensatory behaviors that the body does using the lungs and the kidney. So I hope this gives you an idea about the acidity. This is all just, we've only just covered the topic of alkalinity here. I'm just conscious of time. I think we've been spending a lot of time on this, but I think it's important for you guys to understand this, because you're going to see a lot of people say, oh, Kangen water doesn't have any benefit because it's alkaline and it's going to cause this. But people don't understand this. So this is why I wanted to make sure that I kind of covered this in this particular topic. So the other thing to talk about while we're here is, so we've got all this pH. What else do we need to talk about? So we talked about protons, we talked about electrons, we talked about oxygen, hydrogen. Now, I suppose we could talk about antioxidant, antioxidant property. Now, antioxidation, that's the next topic. We talked about acidity and alkalinity. You understand the pH scale, you understand why the numbers are the way they are. Now, the pH, now, oxidation is, well, first of all, we have to understand what's the purpose of oxidation. Why do we need to know about oxidation? Well, in our body, coming back down to the cellular level this time, our body is exposed to things like free radicals. Now, what is a radical? What is a free radical? What is that? A free radical is a high energy atom, proton, ion, or molecule which can cause major damage in the body. Why? Well, in order to answer that question, or to give you a taste of what a free radical is, we've got to go back to our periodic table, and I introduce you to group 7. Now, group 7 contains fluoride, chloride, bromide, iodide, and all these wonderful atoms here, all these elements. Now, remember we were talking about oxygen not being happy because it hasn't got its unpaired electrons. The unpaired electrons haven't been filled. Fluoride is what's known as the most electronegative atom in the whole periodic table. And the reason why that is because of where it is. There is nothing more electronegative than this particular atom here, because fluoride is, well, let me draw it first of all. So we've talked about oxygen, now we're going to talk about fluoride. So let me just write here F. Find the F here. Right. So fluoride, this time in its outer shell, is got this time 7 electrons. 1, 2, 3, 4, 5, 6, 7. 7 electrons in its outer shell. This particular atom is very unhappy because it wants that atom. It wants that electron. It will fight tooth and nail to get that electron to unite with this in order to make it happy. And what this fluoride does, it rips every single thing it comes in contact with to get that electron. That's how powerful. This can be a free radical in itself. This is why, for example, fluoride in the toothpaste. Now, little side conversation here. Fluoride is in toothpaste. Yes, you're all familiar with the fluoride in toothpaste, right? They did studies on fluoride. One of the things that fluoride does, it wrecks. They took cadavers. They did a study where they looked at 100 cadavers, and they found that when they examined these cadavers, these dead, the corpses, they looked at the pineal gland in the brain, and they found that it was completely corroded because of fluoride. Calcified pineal gland. The pineal gland is supposed to be the gland which represents your ability to have ability to kind of have intuition and all of those things. Very central gland. Go and read about pineal gland. Now, fluoride, what it does, it wrecks the pineal gland, and it actually attracts calcium, and it causes calcification of that area. So fluoride is one of your atoms which will actually cause damage. It's a free radical. So this is an example of where we're trying to introduce ideas about how these free radicals work. So what is the best way to neutralize this? I'll tell you. The best way to neutralize this particular atom is to give it what it wants. Yeah. This is where I usually say to people, what is the most powerful, in what form does the most powerful source of energy in the universe come from? Question I always ask people, in what form does the most powerful source of energy in the universe come from? Any ideas? So I get people telling me the light, the sun. Yeah. It's one simple thing. It's love. And I'll show you. Would you all be interested in knowing what the Kangen answer to love is? I'll show it to you. It's sitting right. It's been sitting here all this time. It's this H2. This here is love. Because these two atoms are two atoms of hydrogen, which basically contain one proton each and one electron each. These two electrons then join together in the middle, and this is H2. This is hydrogen gas. So when you turn your Kangen machine on and you put your water in, and you see that wonderful kind of sort of bubbles that affect, that's your hydrogen gas. When you take your lighter and hold it up against the water stream, you hear these popping noises. What is that? That's your hydrogen gas. That, ladies and gentlemen, is your molecular hydrogen. That is your love. And I'll tell you why it's love. Because what happens is that when you drink this water, this H2, this breaks away as atomic hydrogen. And what this does, it will come and it will unite with this and neutralize this free radical. That is simply how antioxidation works. Proton splits away, this hydrogen splits away its entirety, joins this, and causes HF. There you go. And this will do this time and time and time again. This H2, ladies and gentlemen, is the smallest antioxidant known to man. And why do we know that? Because the periodic table shows that it is the one atom in the corner which has the least amount of protons and electrons. It's the less materialistic. One atom, one neutron, one proton, and one electron. And the electron and the proton, they both cancel each other out. The proton, on the other hand, doesn't have this. It only has a positive charge. That's this thing here, H plus. But H2, as we said before, has hydrogen atom, two hydrogen atoms together, one splits away and then neutralizes it. So that's your antioxidation right there. That's how antioxidation works. So when we measure this, how do we measure this? We measure this with the meter called the ORP. Yes, ORP, oxidation reduction potential. This, when we put this in our beakers of water, will tell us what the charge is. Now, the charge, if it's good, if it contains antioxidant material, it'll give a negative value. Yeah. So ORP, when you measure the beakers, when you measure what's inside the beaker, when you measure the water inside the beaker, what you get is you get an ORP, which is normally, if it's pH 9.5, if you measure the ORP, it's usually a negative number, something like minus 500. But what influences that ORP? What makes it more negative? It's the ionization effect. It's the fact that inside here, when you measure the ORP of the water that is alkaline, which is at this end, what do you have inside here? You have H2O, yeah, which we drew earlier. So inside here, you have, where are we? I'll take one of these again. Copy this. You got this thing here, H2O. Yeah. So that's in the water. What else have you got in water, in the Kangen water? So it's important that we distinguish this. So what is Kangen water? Kangen water is effectively H2O. Yes. You've also got H plus, but not many, because remember it's a low pH. Sorry, it's a high pH, which means it's got less protons. So H plus. And you've also got H2. Yeah. So you've got all of these things in there. You've got H2O, which is this species here. You've got H plus, which is these little green ones. And then you've also got H2, 3 of them. That is, ladies and gentlemen, that's Kangen water. Tap water, on the other hand, only has H2O, H plus, OH minus, but no molecular hydrogen. That's the difference between tap water and Kangen water. That's the reason why Kangen water has those properties, which are, it is antioxidant and it's alkaline. Now we come on to the last part, which is microcluster. Now, microcluster is a name which I find very, just like the pH, the H plus should be pH, right? It's the same that goes for the point about the microcluster. Microcluster is actually a false name. Microcluster is a name that they use to try and simplify things, to give you the impression that it has the ability to penetrate cells, yeah? And then you would have heard in the lecture, this time I'm going to draw here a cell, and in the cell you have what's known as a bilipid membrane, and then you have these little channels, which are called aquaporin channels, and then the H2O gets inside here somehow. That's actually not the case. What we actually find is that it's the protons, H plus, sorry, the H2, molecular hydrogen, because it's so small, can pop into here. Inside here, you've also got water, or OH minus. OH minus, for instance, when you have OH minus, they can fit in here. Yeah. But because you've got such a large amount of OH minuses in this water, because remember, all the protons have been taken out, this gives the negative ORP. The OH minuses contribute to that because they're all ionized. When you drink this water, the OH minus goes through these aquaporin channels because they're small enough. Because look, what's the difference between, I'll draw it here for you, look. You see, you've got this huge atom here, sorry, molecule, H2O, versus, I'll change it to green, this here, which is just OH minus. And when the OH minus goes into this, OH minus, these will unite with the protons that are already in there, yeah, because there's already protons going to be inside, and this joins together and forms your water. That's your microcluster effect. That's the ability for the water inadvertently to get inside. So what you're actually doing is you're hydroxynating the inside of this. And what this does, it reduces the pH, it increases the pH inside the cell. Now, just to end off, because I'm just conscious of time, I think we've gone over, is that one of the things that we should also talk about is blood. Now, how are we going to do this? Let's draw a blood. Let's just draw here a blood. This imagine this is a capillary with blood inside, right? The capillary in blood. Now, the normal pH, if you test the blood, right? The normal pH, if you take a measure of the blood gas of blood, the normal pH is 7.35 to 7.45. That's the norm. Yeah. If you go outside of this and go towards 14, 7.45, 8, 8.1, 9 point, you're getting into the alkalosis. This is an alkalosis situation. If you go below 7.35 to 6.9, this is what happens in diabetic ketoacidosis. You get acidosis of the blood. So this becomes acidic. So what do? We have to try and bring this back into the norm. That's what the body tries to do, yeah? So what happens in the blood is that the pH is usually between it. It tries to fix it. Now, here's another thing that I want to introduce at this stage, and I think it's a very important thing. Let's move this aside. Let's get all our chemicals out of the way. Right. Now, I want to introduce this concept here. Now, if you take a if you take a 70-kilogram man, 70-kilogram man, how many liters? Now, bearing in mind, this here is a bottle. This is a 1 liter bottle I've got in my hand right here. 1 liter bottle of water. How many liters of fluid, not water, fluid? How many liters of fluid is there in a 70-kilogram man? Any ideas? Put it in the chat. I want you to write some numbers in the chat. Where's the chat? Yeah, just type in the chat what you think is the normal liters. I want liters in let me stop share for a second. Right, type in the chat what you think is a normal the normal volume. What's the normal volume of fluid 70 kilogram man? So we've got 45. Any advances on 45? How many of you? Well, there's quite a lot of you. 50, yeah. Anything else? Any other numbers you want to throw at us while we're here? Okay. Well, just because I'm conscious of time, yeah, you're right. 45 liters of fluid in a 70-kilogram man. Now, the question is, how much of that is blood? You want to write in the chat what volume of blood is there that makes up that fluid? Somebody write in the chat. 5, yeah. Anybody else? Right. So again, conscious of time. Yeah, exactly. There's 5 liters of blood in that volume. 5. That's 1/9. Now just imagine, just to put this in perspective, what is the most common test that your doctor sends you for? He sends you for a blood test, yes? So when you go and get your blood test result, would it surprise you to know you're only getting 1/9 of what's actually going on? Okay, how do you like those odds? 1/9. What about the other 8/9? So this is where we have to understand the body. We've got to put the body in perspective. The body has between 37 and 72 trillion cells in the body. So if you extract all the fluid from each and one of those cells, which would be a very painful process, by the way, small needle, small cell, and about 73 billion times you're going to get pricked. Right, 73 trillion cells. You're going to get all these cells. You will get 25 liters of fluid, right? 25 liters. I'm going to put the light on. Can't see. Right, so you've got 25 liters of fluid. Need to put that in here. Change that to black. So when you actually look at the compartments of the body, you have 25 liters intracellular space. Yes. Then you've got 5 liters in the blood. Right. Where's the other 15? The other 15 is in the extracellular space. All of these cells, remember the cell that we got here? All these cells have fluid in, and they also get bathed in fluid. Yeah. So there's fluid outside the cell and there's fluid inside the cell. So when you look at all the fluid, you have 15 in, 25 out, and 5 in the blood. So just imagine when you take something like Kangen water, which is 1 liter, like this bottle I have in my hand, how much of this is going to end up in this intracellular space? At least 25, which is approximately 1/9 is going to end up in the blood. 3/9 is going to end up in the extracellular space, and the rest, the majority, is going to end up intracellular. So can you see now why the water will actually invade every single barrier? Because of the fact that it has that microcluster effect. What you are effectively doing is you're creating a system where Kangen is the most efficient transportation mechanisms known to man, apart from all the other blue areas where you drink those waters where Kangen water is based upon. Those waters will actually penetrate every single cell in the body. And by doing so, it will manipulate the pH. So the pH of blood, as we said, is 7.35 to 7.45. The pH of all these other cells will be round about the same, except when you go into the acid. What about the stomach? We said that the stomach is got an acidic pH of what? 0.5. So what do you think the pH of the cells there are? So what does this tell you? This tells you that we have highly specialized cells to deal with different situations. If you go to the stomach lining, they're made of columnar epithelium, which are designed to produce pHs of that kind. But in the cell itself, because remember, the cell represents a barrier. There's a cell which produces product, And then inside the stomach, which is the lining, which is another huge receptacle like a balloon, right, is your acid. The acid is on the outside of the cell. Inside the cell, the pH is still probably about 7.35 to 7.45. All it's doing is maintaining the internal environment of this cell so that it can produce product. That's what a cell does. A cell produces product. It's like a factory. Just think about workers in a factory. If you turn the temperature down in a factory, will the people inside work productivity? Will their productivity go up if they're frozen? No. Would be able to increase their productivity? No. So you've got to keep your workers happy. So similarly, you've got to keep the pH environment between those figures. So if you increase the pH inside the cell, you'll get benefits. So that's how Kangen water benefits these people. When they did the studies where they showed that when they drank Kangen water for a period of time, the pH environment in the cell goes up, and as a result, they produce more product. And what product are we talking about? Serotonin. Serotonin gives you energy. That's why these people, after 3-4 days, their energy goes up. In the brain, crosses the blood-brain barrier, gets in and produces what? Melatonin. What does melatonin do? It helps you to sleep. That is why you're seeing the benefits of the water when they've been exposed to this, because it's working at the cellular level. So it's a very important ingredient. So coming back to the blood, which I want to end off on, and coming back to the periodic table, I want to show you something. In the periodic table, we talked about hydrogen, we talked about fluoride, we talked about oxygen. Now I want to introduce you to these four here: sodium, magnesium, potassium, and calcium. These are what's known as alkaline metabolites. What do I mean by that? Well, what that means is inside the cell, there is a high concentration of potassium. On the outside of the cell, there's a high concentration of sodium. Inside the bone, yes, let's draw a bone here. I don't know if I can draw a bone, but there we go. I'm going to attempt to draw a bone, guys. Okay, here's the bone. Sorry about this picture, but anyway, there's the bone. Yeah. So the bone contains calcium and magnesium. Yeah. So I'll draw here. Actually, let's do it properly. So you've got Ca, calcium, and magnesium, right? So these form, now these are all cells. This is the cells of bone. This is the cells of any normal cell. When the calcium, magnesium, and potassium and sodium, right, in the extracellular space, when you start to get a situation, for example, where the pH in the blood, now blood, remember, goes around the whole body. If you start messing around with this pH, for example, we start to make this more acidic. How do we make the pH in the blood more acidic? The kinds of food that we eat. If we eat a lot of flour, a lot of processed foods, it's going to affect the acidity in our blood eventually. And when this becomes acidic, what do you think the body does? The body now calls upon sodium to go into the blood, potassium to go into the blood, calcium to go into the blood, and magnesium to go into the blood to try and bring the pH back towards normal. What do you think is happening here? That means that we're getting deficiency in sodium, potassium, calcium, magnesium in these areas. And if this continues to happen and the pH in these cells start to go more acidic to compensate for the blood, what do you think is going to happen at these areas? When you increase the acidity in cells, do you guys remember a guy called Otto Heinrich Warburg, 1931, who won the Nobel Prize for what? For discovering that if you increase the acidity in the cell, you get prone to what? Cancer. Because those cells now are going to try and compensate, because what you've done is you've wrecked this pH environment in those cells. And when they start to become more acidic, cancer comes in. So you have here osteoporosis, which then becomes osteocarcinoma. You get, for example, if this is a liver cell, hepatitis, then becomes hepatocellular carcinoma. You get, for example, in the brain, you'll have meningitis, meningogliomas, and meningiomas. This is where you start to get cancer growing. So when you start to correct the pH, and it's going to benefit people in that way. So I wanted to end there just to give you an idea of how the Kangens work at the molecular and cellular level at the level of the level, so that you can understand the interaction of why those three alkaline cluster, how all three of those work in synergy to gain or to have benefits on the patients who drink this water. That's why you're going to see people going to reverse a lot of the inflammation in their body, because they're going to take out some of they're going to neutralize some of the free radicals in their bodies, which are causing damage. So I think we'll end there. If you've got any questions, I'm happy to answer them. I'm very sorry I went a little bit overboard, but I think, you know, it gets really interesting, so I get a little bit carried away. So I apologize. So yeah, thank you very much, guys.
Awesome, Dr. Imran, thank you so much. That was amazing. So let's give a warm thank you to Dr. Imran for the presentation. Now, if you have any questions, Dr. Imran, do you have a few minutes to answer questions?
I'm here for you guys. Just
okay, perfect. So we have Sakirat, raise your hand. Please unmute yourself and go ahead.
Yeah, good evening, doctor. Good evening, everyone. Thank you so much. Yeah, that was a brilliant one. I just wanted to get the third part of the Kangen water. I think you mentioned about alkalinity. You mentioned about function for oxidation, and the third one is what I didn't get. Is it mycotoxin or something?
It is microcluster, but what I would say is
microcluster.
The terminology that we use to try and summarize the fact that the water has the property of penetrating cells and penetrating barriers, which we have many.
Okay.
We have the blood-brain barrier, we have various barriers in our body. The water can penetrate that. You may have seen people do tests with the teabag test. Now, there is a lot to say about that. There's a lot of intricacies about whether that teabag test actually does demonstrate that. It demonstrates an idea, but at the end of the day, it's basically what I say is that it's a combination of vibrational energy as well as the molecule that's actually doing that work. So it's just really they have to find some terminology that they could use to summarize that property, the ability of the water to penetrate cells at the cellular level so that people get the benefit. And that is one of the contributing factors.
Thank you. Thank you so much.
Awesome. Anyone else have any questions, guys? Let's take 2 more questions if anyone have.
So I think people want some replays. I don't know if you guys have recorded this. So if you've recorded it, then I think the person to speak to is probably Anthony Tan or Dr. Doblet. I think they'd be more than willing to help. Perhaps you could, if you want to release that. So yeah,
awesome.
I'm happy to that.
Got a question.
Okay, Lena, go ahead, Lena.
Dr. Imran, can you explain about the pH, the strong acidic water? Does it, okay, it's strong acidic water, Kangen strong acidic water is hypochlorous acid, am I right? So I have read a lot of scientific studies that this strong acidic water is effectively heal a lot of skin diseases. Because it kills bacteria, viruses, and pathogens 30 seconds. Can you explain that, please? Thank you.
So the question is about the acidic water. Now, when you talk about acidic water, there are 2 types of waters we're talking about here. So when you set your machine, now you're talking about strong acidic water. Now, strong acidic water is only formed when you use the salt solution which you add in that compartment, which is a liquid. It's hypochloric, or is basically a hypochloric solution, which what it does, when you go through the electrolysis process, remember we said to you there is the side which produces the acid and the side that produces the alkaline. So the alkaline now becomes full of hydroxide ions, which are OH minus. Yeah, all the protons have been taken out. So those OH minuses need to latch onto something. So how do we increase the alkalinity? By using the hypochloric solution, because the hypochloric solution is a salt solution, basically. And the sodium from that latches onto the OH minus, pushing the pH more towards 14. So it comes up to about 11-ish, right? On the other side, which is what you're talking about, we have loads of H plus protons in the acid. They have to latch onto something. So they will latch onto Cl, forming hydrochloric, and OCl, which is HOCl. So HOCl is a weak acid, HCl is a strong acid. So with the two together, and because of the sheer numbers, you now have a solution which contains both HCl and HOCl. Now, what we've done is we've done loads of studies which show that the acidity, the pH of those solutions of HOCl and HCl are around about between 2.5 and they range up to 5.5. So when they looked at bacteria and viruses and various other of those pathogens, what they found is that those particular acidity levels can actually take out a whole colony of bacteria, but in a certain range. So even though you use, for example, pH 5.5, which is beauty water, which you spray on your skin, which is HOCl, yeah. Well, actually, no, it's not HOCl because you haven't introduced the chloride in there. So what you got is just basically water, which is full of protons. Yeah, it's only when you have the pH 2.5 that you get the HCl and the HOCl because you've introduced the salt solution into the mix. Some people, what they do is they pull the compartment out. They pull the compartment out and then press the strong acidic button. What you're still getting there is acidic water, so it won't be as higher a pH as when you put the salt solution chamber back in, which then draws the salt out so you can get NaCl, which is the alkaline. And as you've rightly said, the acidic water is hypochlorite solution with HOCl and HCl. And they are very, very strong bactericidal. They're very, very strong. They can kill bacteria because using oxidation, so it oxidizes them. So yeah, you're absolutely right. They do have that effect, and you can actually spray them on your hands. During COVID, it was very, very effective against keeping areas clean, and you can actually use it as a sort of as an antibacterial. So yeah, absolutely. HOCl and HCl, they have that effect. So it's a mixture of the two, because remember, you've got protons which will mop up chlorides, and you'll have protons which will mop up OCl. So you get hypochlorous and hydrochloride. So both of them work together as antibactericidal, and they're very effective in that respect. Hope that answers the question.
Okay, thank you. So just one question, refer to the same question. Sophia here, Centric Estate.
Hello there. Hi, hi, Lena. Lena introduced me to Kangen water. I do have a couple of questions because I went to Lena's place. Very kindly, she shared me some acid water and alkaline water. Yeah. I have MC, molluscum contagiosum. I tried the acid water. Yes, Dr. Imran. For some reason, it does not react to it. It just keep growing. So at the end, I have to use a steroid to control it. And funny enough, I bought this medicine from China all the way. And Hong Kong would not allow this prescription, or UK. I managed to get under control with this medicine.
So what you have here, I'm going to draw it out here for a second. Hang on. If you okay, so if we draw here, actually, wait a minute. Okay, so if you draw here the lung, okay, this is the lung, yeah. And on this side you've got the kidney. Oh, that looks like a kidney. Right, now there is a formula which goes like this. Right, so you've got H2CO3, right, which then goes to H2. Actually, the other way around, isn't it? Let's see, we'll get rid of that. Okay, so we start here. So you have here CO2 plus H2O. Right, they will go in this direction to what's known as H2CO3. And this will then go towards H plus HCO3 minus. Yeah? And it goes in the opposite direction as well. Yeah, it goes in the opposite. It goes that way and this way. So when you produce this proton here, if you push everything this way and you produce loads of proton, this is acidic. When this goes up, when these two go up, it drives the reaction the opposite way. And what happens is it combines to HCO3, and H2CO3 then produces water and carbon dioxide. When you produce carbon dioxide, you start to blow off, you start to hyperventilate. When you hyperventilate, that brings this protons down, and what that does, it brings the blood back into normal. So this is what's happening, guys. Your kidney, on the other hand, excretes protons in the urine. So your urine becomes more acidic. So when you pee, you start peeing yellow. It's more acidic. And then